class. So 5.1, we have done our correlation. Correlation is used to determine the relationship between two variables. Okay, and then we have calculate the R to determine the strength and the direction. We also calculate the R square to determine the variation. Okay, so now we have 5.2, simple linear regression model. Okay, simple linear regression model. So by the end of this topic, you should be able to write a mathematical equation that relate dependent variable y with the independent variable x. So now you will have this equation. Okay, so now next, draw the regression line or the best fit line. Interpret values of intercept and slope, and then use the equation to estimate values. So, okay. Simple linear regression model. Okay. Regression is a statistical measure that attempts to determine the strength of relationship between dependent and independent. So when we talk about regression, we talk about relationship between what? Independent variable and the dependent variable x and y. Okay. Simple linear regression model, SLR, simple linear regression model is a model with a single x. Simple linear regression model is about 1x and 1y only. Okay, when you have more than 1x, it will call as multiple linear regression. But now it is a simple linear regression. It is only 1x and 1y, one independent variable and one dependent variable. So can be presented by equation of a straight line. So actually it comes from here, y equals to mx plus c. Okay, this is actually a straight line, also a simple linear regression equation. Okay, when you have more than one x here, it will become multiple linear regression. So we look at simple linear regression first when you have one x and one y. Okay, simple linear regression model. This is an equation. Model is the equation. So y equals to beta naught plus beta 1x epsilon. Okay, here is general equation where your beta naught is the intercept and beta 1 is the slope. Okay, we will use method of least square to estimate the parameters. Okay, because this one is the general for the population. Okay, we take sample to estimate this population. So when we estimate, we want to estimate this beta 1 and beta naught. Okay, we estimate, right? This one is the general for the population. So when we take sample to represent this population, we will use estimation using least square method. So when we estimate, the beta naught and beta 1 just now will become this beta naught cap and beta 1 cap. So if you notice here, this one is beta naught without cap, this one is beta naught with cap. Beta naught with cap means that estimation. Use sample to estimate the population. Beta 1 cap is the estimation for beta 1. Okay, so y cap here means that this is an estimation. Alright, because we estimate the population based on sample. So where y bar is the estimated dependent variable, x is the independent variable, beta naught cap is the estimate of the y-intercept, beta 1 cap is the estimate of the slope. Okay, so your task now is you have to find what is the beta naught cap and beta 1 cap value. Okay. After you got the beta naught cap and beta 1 cap value, you can write down this equation. So this is a simple linear regression model. Simple linear regression equation when you have only one x. How to calculate the beta 1 cap and beta naught cap? Okay, the equation, this formula is given in your step table. How to calculate beta 1 cap? How to calculate beta naught cap? We will calculate beta 1 cap first. Beta 1 cap is equals to sxy divided by sxx. So, from you calculate the R, you got the all the SXX, SYY, SXY. So that values of SXY and SXX you bring here. You will get the beta 1 cap. Okay, how to get beta naught cap? Once you get this beta 1 cap, you can find your beta naught cap. Okay, what is X bar and Y bar? X bar is the average data X, Y bar is the average data Y. You can get from calculator. Okay, so here is the recap how to find SXX, SYY, SXY. Okay, X bar here is the average data X, Y bar is the average data Y. So actually the X bar and the Y bar you can get from calculator. Right? So the beta naught and beta 1 you can check also using calculator. But you have to calculate it first. After you calculate, you can check using calculator. Okay, these are the properties of simple linear regression. So I think this one you can just read on yourself. So the guideline for using simple linear regression, if there is no linear correlation, do not use regression equation to make prediction. Means that you said that there is no linear correlation. Okay, no trend. So you cannot use the regression equation to make prediction. Next, when you're using the regression equation for prediction or for estimation, stay within the scope of the available sample data. Okay, cannot do extrapolation method beyond of your sample data. Okay, a regression equation based on old data is not necessarily suitable for current data, and then do not make prediction about a population that is different from the population which the sample data would run. Maksudnya kalau ambil population tu guna sample tu lah. So sample tu hanya boleh predict untuk population itu sahaja. Okay. Next. Example. Example 5.4. Okay, using data from table 1, calculate the slope and y-intercept of the linear regression line, then write its equation. Okay, this one is about the data marks and final exam marks and hours. Okay, calculate the slope and the y-intercept means that calculate the beta naught and beta 1. Slope is beta 1, y-intercept is beta naught. And then write its equation. Okay, and then interpret the values of intercept, beta naught and beta 1. Okay, beta 1 is the slope. Beta naught is intercept. And then last, use the equation to predict what marks would be observed when the number of hours are 16 and 20. Okay, this one is the data that X is hours, Y is marks. Okay, the previous example. So, the previous example, we have done our R, we have done our S, X, X, Y, Y, we have done. Okay, now we want to calculate beta naught and beta 1. So, the beta naught, first calculate beta 1. Beta 1 is equals to SXY divided by SXX. So, you just divide it, you will get 4.0593. Okay, X bar, calculate it, you get 10.25. Y bar, you get 68.5. So, using this X bar and this Y bar, you can get the beta naught 26.8926. Okay, so substitute this beta naught and beta 1. Here is beta naught, here is beta 1. You will get the regression line. Okay, so now you have got your regression line. Y cap is equals to 26.8926 plus 4.0593x. This is your simple linear regression model. Simple linear regression equation. Right, next, interpret y-intercept and the slope. Okay, interpret y-intercept. Y-intercept is beta naught. So, beta naught is equals to 26.8926 26.8926. So interpret this one. What does it mean by 26.8926? Means that when the hours spent to study is 0, the mark predicted is 26.8926. Okay, when this one is 0, when the hours is 0, the marks will be 26.8926. That does it mean by the beta naught. How about beta 1? Okay, beta 1 is equals to 4.0593. What does it mean by 4.0593? Means that the mark increased by 4.0593 for every hour students spend to study. Okay, that one is the for slope here. The marks increased by 4.0593. Let's say you get your B1 negative 0.4593. You cannot say increase. You have to say decrease. Okay. So now you get the equation. The last is you want to predict. Okay. Our equation just now is y cap is equals to 26.8926 plus 4.0593x. So the equation is estimate. Okay, the equation is the question is predict what marks would be observed when the number of hours are 16 and 20s. So when your x is equals to 16, what will be your y? When your x is equals to 20, what will be your y? Okay, how you want to get your y? You just put the x into your equation just now. Okay, we got our equation just now. So our equation just now is this one. Okay, first you substitute x equals to 16 here. You will get 91.8414. When you substitute x equals to 20, you get 108. So this one is not. This one we call it as extrapolation. It's not logic because marks cannot be exceed than 100. Okay, this one we call it as extrapolation. Why? Because when you substitute x equals to 20 here, you got 108. So marks cannot exceed 108. Marks is only 100%. When you got beyond of that, we call it as extrapolation. So you cannot do prediction for this one. Okay? So before you do this exercise, we recall a little bit. Okay, what you have done is actually in simple linear regression, first your equation. Okay. Y cap equals to beta naught cap plus beta 1 cap x. So this one is simple linear regression model. Okay, you have to find your beta naught cap, you have to find your beta 1 cap. How to find beta naught? How to find beta 1? Here sxy divided by sx. Okay, here is y bar or x bar. So you can check the formula here. And then after you got the beta naught and beta 1, you just put into this equation. So first you have to know to write down the simple linear regression equation. And number 2, you interpret beta naught and beta 1. And then number 3, you estimate. Okay, so you will see later on when we do the exercise. Exercise 5.2, number 1, about the simple linear regression. So actually it is related to the 5.1, correlation coefficient and the coefficient of determination. Okay, a study is conducted to investigate the relationship between the cause of fire damage and the distance between the fire station and the location involved in the fire accident using regression method. The data is given as follows. A. Identify the independent and the dependent variables. So I will use IV for the independent variable, DV for the dependent variable. So what depends on what? Is it cost depends on the distance or distance depends on the cost? Cost depends on the distance. Alright. So the dependent will be the cost and the independent will be the distance. Okay, B. Draw a scatter diagram and give comments. So I hope you can do it for yourself. Do it yourself for B. Okay, for C, calculate summation y square, x square, and xy. So put it into your calculator, come up with all the summation. Summation of y is equals to summation of y square Okay, and then calculate correlation coefficient R. So R, so I give you the answer. Okay, you calculate the SXX. Okay, SXX is equals to 180.02 minus divide by how many data we have here? 12. So SYY is equals to y square minus y .37.3625. So SXY is equals to 342.7 minus so you will get 111.96. Okay, done. So R is equals to 0.9541. So strong positive linear. Okay, R square is equals to 0.9102. So 91.02% variation in cost can be explained by distance. Okay, D settle, E pun settle. Estimate the regression parameters and write the estimated linear regression model. So mean here you have to find the beta naught and beta 1. So now find the x bar first. So x bar is equals to 3.6333 and y bar is equals to 28.225. So beta 1 is equals to SXY divided by SXX. So our SXY 111.96 divided by SXX 21.6067. So beta 1 is equals to 5.1817. So beta naught is equals to y bar minus beta 1 cap x bar. So y bar is 28.225 minus, okay, ini panjang sikit. So beta 1 is equals to y bar minus beta 1 cap x bar. Okay, equals to 225 minus beta 1 5.1817 x bar 16333. So beta 1 is beta naught is equals to 9.2 9.3980. Okay, so write the estimated linear regression model. So the estimated linear regression model is y cap is equals to 9.3980 plus 5.1817x. This is your simple linear regression model. Okay, so continue here. Y cap is equals to 9.3980 plus 5.1817x. This is our equation just now. So the question is, predict the cost when the distance is 10 kilometer. So when x is 10, what is your y? And then predict the distance when the cost is 10. When the y is 10 million, what is your x? Okay. So we do HI. H when x is equals to 10 kilometer. So y cap is equals to you substitute x equals to 10. Okay, so here you will get RM 61.155 million. Okay, for I, predict x when y is equals to 10 million. Okay, so 9.3980 here is 10 plus 5.1817 x. So you will get the x is equals to 0.1162 kilometer. Okay, so use this equation. So make sure this equation is correct, then your prediction is correct. When you are wrongly calculated your beta naught and beta 1, your equation is wrong. Okay, when you wrong calculate all the summation, your R will be wrong. So it is related to here. Okay, actually it is related to this one. When you wrong determine your x and y, all will be wrong. So exercise 5.2 number 1, please try on your own. Thank you.